Now, there are some problems which are not exactly in the Basel Sodi form. So, in bracket, you can see some substitutions are given. So, by using those substitutions, you can convert the mentioned ODE into Basel Sodi. Okay, that problem number three that is given in my handwritten note. It is solved in my note. You can verify it. You can check it from there. I am showing problem number four. And actually, these two step substitutions. These are very difficult. You can do it, but it will be very larger actually. Two-step substitution means like problem number 6. Can you see? Means if first of all you have to take y is equal to u root of x, then you take root of x is equal to z. So it is a two-step substitution. So that will be difficult. You can ignore it. These are not in your syllabus. Two-step substitution. Only you try those problems which is in which means one only one substitution is used, like 3, 4, 5, 7, okay, 8, 9 also, not 10. Now I'm showing problem number 4. So it is problem set 5.4 and problem number what I told 4. Okay, problem number 4. Y double dash plus what? Take it is given that take e to the power minus x is equal to
So that is 1 by 9.
huh? 1
So
by
1
9.
by
Yes. 1 by 9. You see, y double dash plus e to the power minus 2x minus 1 by 9 y is equal to 0. So there are no proper way to understand what kind of substitution will be used. Have to take. Okay. So it will be given with the problem what kind of substitution we have to take to reduce it to Basel sodium. So e to the power minus x is equal to z. That means what? Which variable we are substituting? We are substituting independent variable, right? Here y double dash means d2y dx2, and we are taking this substitution e to the power minus is equal to z. It is a relation between x and z. So we are substituting basically the independent variable. Is that clear to you? So you have to reduce y dash and y double dash. Y dash means dy by dx. Dy by dx to which form? Some dy by dz form. Okay. And y double dash, it is also d2y dx2. Reduce it to, convert it to the form of d2y dz2. Now, dx of dy by dx. So what I can write? Dy by dz into dz dx. Can I write this?
Yes, sir.
Now what is dz dx? So from this substitution, if you differentiate it with respect to x, it will be dz dx. It is what? This, right?
Yes, sir.
Yes, sir.
So it is basically minus e to the power minus x dz, sorry, dy dz. Now that x should not be there because we are converting x to z. So ultimately I can convert it to z, e to the power minus x, it is z now. So minus z dy dz. Okay. Now second derivative. So d dx of dy by dx I can write. Therefore d dx of minus z into dy dz. Now it can be written as d dz of minus z dy dz into dz dx. Can I write it? Is everything clear or not? Tell me. Any doubt anywhere?
No, sir.
No, sir.
Okay, now you can substitute that dz dx. It is what? Dz dx, it is minus e to the power minus x. That means minus z. So minus z bracket. Now you perform this differentiation. Okay. So d dz minus z d2y dz2 plus, if you fix dy by dz, it will be minus 1. So ultimately minus dy by dz. Any doubt here?
No, sir.
Anyone?
No, sir.
Okay, now you multiply it. It is z square d2y dz2 minus, not minus, it is plus z dy dz. Now we can substitute this y double dash and y dash into the equation number 1. Okay, substituting y dash and y double dash into equation number 1.
Sir,
Yes.
so can you explain that part again, sir? That previous part.
Where? In
So
which
the
part?
second last. Minus
Second
z.
part.
Yes.
Okay. See, d dz of this dz dx, two part. Okay.
Yes, sir.
This part is clear up to that part.
Yes, yes, sir.
Okay. Now, what is dz dx? You will
Minus
see
e
here.
to the power. Yes, sir.
Minus e to the power minus x, and e to the power minus x is z. So I can write minus z.
Yes,
Okay.
sir. Acha.
I have written minus z here.
Yes, sir.
for dz dx, and for the rest d dz of minus z dy by dz, it is a product of two terms. So I am applying multiplication rule, d dz of this. So minus z fixed, d dz of dy dz, that will be d2y dz2. And if you fix dy dz in the next term, then d dz of minus z is minus 1, so minus dy dz. Is that clear to you now?
Yes, sir.
Okay, now from 1 you substitute y double dash plus this minus 1 by 9 y is equal to 0. So it will be z square d2y dz2 minus, sorry, not minus, it is plus or minus plus z dy dz plus, and e to the power minus 2x is what? E to the power minus x is z. E to the power minus 2x will be z square, right?
Yes, sir.
Z square minus 1 by 9 y is equal to 0. Is not it a Bessel's OD? Only the dependent variable it is changed. The form remains same. Sorry, independent variable. The Bessel's equation has been given in the form of y and x, and it is in the form of y and z. Whatever means the form looks similar, right? Do you get it or not?
Yes, sir.
And what is new here? 1 by 3? Why are you not replying? Tell me. It is 1 by 3, right? New 1 by 3. Z square minus new square. What is the form of Bessel's ODE? Do you remember? X square y double dash plus x y dash plus x square minus new square y is equal to 0. It was the form. Same form, na? Here, if you compare with that, what is new? 1 by 3.
Yes, sir.
So, new 1 by 3. Therefore, can I write the general solution?
Yes, sir.
Look, here no need to uh, apply Frobenius method. Okay, directly you can write the solution after substitution. Directly you can write the solution in terms of Bessel's function. So can I write uh, the general solution here? Nu is fraction. So in the last class I told if nu is integer, then we cannot write the general solution in the form y is equal to c1 j nu plus c2 j minus nu. If nu, again I am repeating, if nu is an integer, then we cannot write the general solution in the form of c1 j nu x plus c2 j minus nu x. But if it is not integer, then we can write the general solution in the form y is equal to c1 j nu plus c2 j minus nu. So here I can write the general solution. What is the variable? Normally the notation j nu x. Bessel's equation. Sorry, Bessel's function. What is the variable here? Z. Right? Or we can write in terms of x also. So substitute it. J 1 by 3. Z is what? E to the power minus x.
Yes, sir.
That is the solution. Okay? General
Yes, sir.
solution of the Bessel sorting. Now see, in my note, I have solved problem number 3, and after taking the mentioned substitution, uh, we are getting the Bessel's form with mu is equal to 0. Okay, here mu 0 na, z square minus 0.
Yes, sir.
Look, you have to be careful here uh, for that particular problem. The final form, it is not coming exactly to the Bessel's form, but after multiplying z square, you can convert it to Bessel's form. Okay, you think about these two lines, how we are getting the Bessel's form. So according to the last form, according to this line, the value of nu, it is 0. So 0, which is an integer. Okay. Now the question is, can we write the general solution? Can we write the general solution?
Yes, sir.
But I told so many times, you should answer. Whenever nu is an integer, we cannot write the general solution. Means what will be the solution? If you try to write y is equal to c1 j0 z plus c2 j minus 0 z are not the same. Matlab, this and this
Yes, sir.
are they independent? No. For integer case, I have shown that jn and j minus n, they are not independent, they are dependent. So that cannot be general solution. Suppose we are getting value of nu is equal to 9, sorry, nu square 9, so nu 3. So if we got the value of nu is 3, can we write the general solution?
No,
Means
sir.
can we write this solution? C1 j3x plus C2 j minus 3x. Can we write it? No,
No, sir.
because these are dependent, right? These are dependent. Dependent solutions do not give us general solution. Okay. So for
Okay, sir.
integer, ultimately what we can conclude, if we get mu is equal to some integer, what we can conclude about the solution? So we cannot conclude about the general solution. The ultimate statement I can tell, that is one solution is j naught, that variable, independent variable. One solution I can mention. I cannot write or I cannot tell anything about the general solution. Okay. So whenever you are getting integer, in that case you mention that one solution is this, but we cannot conclude about general solution. But if nu is not an integer, In that case, we can conclude about the general solution. I have told these things at least 10 or 15 times. I don't know what you will do in the exam. Okay, so similarly, you can do problem number 5. Okay, problem number 5. Uh, you take lambda x is equal to z, and then similar process you follow. You substitute the variables and their derivatives. Okay, here also Here also for the problem number 7, we are substituting the independent variables. Problem number 8, we are substituting the independent variables. But see, problem number 9, it is something different. Don't you think? Here we are not substituting what? Here we are not substituting the independent variable. We are we are taking a substitution on the dependent variables. Why? We are changing y to u. Okay, so here what will be the relation between the derivatives? Means dy by dx, we will convert it to what? Can you tell me? If we take this substitution, then these derivatives are what? Dy by dx, d2 by dx2. This will come in terms of du dx, something into du dx. Okay, similarly d2 by dx2, that will come also in terms of d2u dx2 and du dx. Do you get it, the difference between this problem number 3, 4, 5, 7, 8 with that problem number 9?
Yes,
3,
sir.
Yes, sir.
3,
Yes, sir.
4, 5, 7, 8. For this problem, I am substituting the independent variable. And for problem number 9, I am substituting dependent variable. Why? So I will see in the next class that solution of problem number 9. Okay. The next class you tell me what will be the solution.
Okay, sir.
Here I am giving you the hint, since the substitution is y is equal to x to the power what? Nu or minus x to the power minus nu into u. Therefore, y dash, that is dy by dx, it will be changed to du dx. Okay, something into du dx you will get. And for y double dash also, you will get something into d2u dx2 plus something into du dx. In that form you will get. Then you substitute it and write the solution. Okay, now we will go to the another type of problem. See, this 19. 23 So you have to use these four properties to prove this. Okay, first of all, you tell me how to prove J naught dash x is equal to minus J1 x. First of all, you write the properties. What are the properties? Tell me one by one those four properties. Tell me. X to the power nu j nu x derivative is equal to what? You should remember x to the power nu j nu minus 1, right? Then x to the power minus nu j nu x derivative is equal to minus x to the power minus nu j nu plus 1
X.
x, and another two
J nu minus 1 x.
minus
So plus then
one about minus, another about
minus
plus.
nu plus 1 x is equal to 2 nu j nu
What?
2 j nu x. Um,
Two genu? No, no.
To genuine dash.
Yes. Two genu dash or genu dash?
so 2 j nu x.
And j nu minus 1 plus
X
j nu
nu
plus
plus
1
1
x
is equal to 2 nu by x uh, j nu x.
this, right?
Yes.
You can check it once. Just one. Here I have done. For plus, it is 2 nu by x j nu x, and for minus 2 j nu dash x. Okay, and last two properties also you can see. Means first two, uh, that is x to the power nu j nu whole differentiation x to the power nu j nu minus 1, and x to the power minus nu j nu whole differentiation minus x to the power minus nu j nu plus. Yes, everything written correctly. So now you think, to prove it, which property I have to use. Now we will get this result by directly putting the value of nu, or after repeated application of these properties. It's not we may or may not get this result directly. So are we getting the result directly after putting any particular value of nu in any of these properties?
So third no होगा.
Third,
Second.
Sir, second one. New,
second one. So
the value of new equals 0.
if you put nu is equal to 0 in the second property, so it will be j nu x. It means j0 j naught x dash is equal to minus j1. Correct. So if we take nu 0 in, say, property number, it is 1, 2, 3, 4. So in 2. Okay. So we will get, देखो x to the power 0, it is 1, j 0 x dash. So it will be j 0 dash x is equal to, and right side minus 1 j1 x, so minus j1 x. So we are getting directly, actually it is the simplest one. We are getting directly this desired result. Now take another. J1 dash x is equal to j naught minus j1 by x. J1 dash x is say a, b. J1 dash x is equal to j naught minus what? j1 by x. j1 by x. Now, is it a direct application of any property?
No,
sir.
sir.
No, then how to prove it? Look, it is first of all, it is related to derivative. So you will get derivative. Look, j1 dash x. So how to get j1 dash x? Here, by using the property 1, x into j1 x into j1 x whole derivative is equal to x into j naught. So from that, can I get the desired result? If we apply the third, and if we take nu is equal to 1, it is j1 and j2. So j2 we don't need. Better you try to apply property number 1. Okay. Now according to property number 1, we are taking say nu is equal to 1. Fine. We are taking nu is equal to 1 in property number 1. So it will be x j1 x x j1 x whole derivative is equal to this side x j naught x. Okay. Now ddx of x j1 x, it will be what? ddx of x j1 x. So x j1 dash x plus j1 x is equal to x j naught x. Okay. Now I can write x j1 dash x is equal to x j naught x minus j1 x Therefore, j1 dash x will be, you divide it by x, you divide the whole equation by x. So j naught x minus j1 x divided by x. Is not it the required proof? Yes, I got it. So do you get it or not? In property number 1,
So can you show the next page?
in property number 1, I have put nu is equal to 1.
Yes, I got it.
Simple one. But sometimes you may be confused that which property I have to use. So you need practice for that. Look, here means that the same problem, it can be tackled by another way. You don't think that there is a single way to handle it. There are many ways. So to prove j1 dash x is equal to j0 minus j1 by x, first of all I am using property number 4. So in property number 4, see I am putting in this property number 4, which one is property number 4? I think this one. According
Yes,
to
sir. Yes, sir.
third one is the property number 4. Okay, in property number 4, I am putting nu is equal to 1. So it will be j0 minus j2 is equal to 2j1 dash. Right. So we are getting that by property number 4 according to the book. If we put nu is equal to 1, it will be j0 minus j2 is equal to 2j1 dash. Now in the required relation, we don't have j2, right? We have j1, j1 dash and j0. So j2 is not there. So next we have to think that how to replace that j2 by j0 and j1. So for that we are using property number 3 to replace j2 in terms of j0 and j1. In property number 3, I am putting nu is equal to 1. So it will be j0 plus j2 is equal to 2 by x j1. Now j2 will be 2 by x j1 minus j0, and then you substitute that j2 in the equation number 1. You will get the result. Okay. So here I am using two different properties, but in the Jamboard which I have shown, only by using one property I am getting the result. You can do any technique. Fine. And there have another like that last one, j2 dash is equal to 1 by 2 into j1 minus j3. So it is a relation between j2, j1, j3. j2 not exactly j2, j2 dash. Now you think what will be the value of nu and which property I have to use. Which property or which properties? Okay, that is your task. So in the next class, I will ask this also. Fine. This one and which one? Your homework is problem number 9. Okay, and one more thing left actually, that is related to integration. So integration of Bessel function. So there are some problems related to integration of Bessel function. I will discuss this in the next class, and that will be the last class of this chapter 5. Okay, that will be the end of chapter 5, and next we will go to chapter 6. These are formula based. Chapter 6, Laplace transform. I think you will you will be enjoying it.
Hope so, sir.
Okay, very soon I will take a quiz test, so be prepared. Mostly on that chapter 5.
Yes, sir.
Not me, actually, it will be conducted centrally and will be announced very soon. I am taking attendance now. Respond quickly and try not to write in the chat box. 742,
Yes, sir.
44,
Yes, sir.
45,
Present, sir.
46,
Present, sir.
47,
Present, sir.
48,
Present, sir.
49,
Present.